Now we are starting with the second use of electrolysis, or you can say the third step of the metallurgy, that is the electrolytic reduction, right. See, the electrolytic reduction, again we'll split into two halves. As you know, what is reduction? Reduction is a process in which the oxygen is lost, right, and in this process the we'll just the oxygen will be loose at the cost of electrolysis, right. It is actually a third step of metallurgy which involves the conversion of metal oxide into metal. That means at the end of reaction, what we are going to have that this metal oxide will be reduced to the metal and oxygen. That means the metal will just get separated and the oxygen will get separated, right. So just look at the board for which the metals we do electrolytic reduction, and you should keep in mind the metals which you can say which occur at the top of reactivity series, they are mostly reduced by the process this electrolytic reduction, right. So just look at the board that in this case what kind of anode, cathode or electrolyte we are going to use. So again, as you know that as you are just familiar with the term electrolysis, that the same thing which we will be doing here, that means on passing electric current, electrolyte will dissociate into ions, right. And as you know, it is carried out in electrolytic cell. So again we are taking into the consideration the electrolytic cell. And as we talk about the electrodes, so again we have two electrodes, anode and cathode. That is, the one which is attached to the negative terminal is cathode and the one which is attached to the positive terminal is anode. As you can see, it is anode and this is cathode. Again, we will be taking an electrolyte as also in it. So we take, what electrolyte do we take? We take actually a salt solution, again a solution which just dissociate into ions when electric current is passed. So in order to make it more easy for you, I will just take an example of some metal oxide, then I will tell you that how we can reduce it, right. So the example which I am taking is aluminium oxide. Right. This aluminium oxide can be reduced into aluminium and oxygen, or this can be aluminium oxide can be separated into aluminium and oxygen by the process this electrolytic reduction. So what we are going to take, the anode, cathode, or which material we will be using, or which electrolyte we will be using, or what else we are going to add into the electrolyte, just look at the board. So what I am doing is, anode is again a positive terminal, same, cathode is again a negative terminal. They are made up of material graphite, right. As you know, graphite is a allotropic form of carbon and it is best suited to make electrodes. So that is why graphite is just taken as an electrode material, right. Then what electrolyte we will be taking in it? Electrolyte will be aluminium oxide. In this case, like we want to reduce aluminium oxide, so that is why I am just taking the electrolyte as Al2O3. But you know, sometimes what we do, whenever you get a question that why this substance is added to an electrolyte, why this and this substance is added to an electrolyte, the answer remains the same, because whenever we add certain substance to an electrolyte, it means the same. That means it should function as an electrolyte in a proper manner. And what is that proper manner? Is that means when on passing current, it should fully dissociate into ions. So like in this case, what we add, in this case we add two substances, Na3AlF6 and CaF2. This is a cryolite. It is again a ore of aluminium, right. So this is a cryolite and this is a feldspar. Now what is the function? As I told you, when we are adding certain substance to an electrolyte, directly or indirectly, it means the same, it serves the same function. That means it is increasing the degree of ionization. So here the cryolite and feldspar are just serving these functions, that they are lowering its melting point. Again, indirectly it has an effect on the increasing the degree of ionization, because lower will be the melting point, more easily it will get ionized, or it will just get ionized completely. So again, it is just indirectly affecting the degree of ionization, right. So this is what I told you, that when we add any substance into an electrolyte, it serves two main functions. One is that to lower the melting point of the electrolyte, and second is to increase the degree of ionization. That means when we pass electricity, it just gets completely dissociated into the ions, right. So this is what we have. Again, I am writing here that we are adding the cryolite and we are adding the feldspar. See, whenever you are attempting in a question like this, you need to just make a well informative diagram which includes the anode, cathode, the material, the ions movement or the ions dissociation. If your diagram will be completely labeled and will be more informative, then you will get very good marks, right. And likewise, you need to write the headings as well and just indicating that what kind of anode, cathode and electrolyte you are using, so that your examiner should clearly see that yes, you know this and you will get a full marks. So don't write in a don't make a paragraph sort of thing, just write, make the headings and just write directly that what kind of anode, cathode and electrolyte what you are using, and if you are adding a certain kind of substance in an electrolyte, that what function it is serving, right. So it should be very clear and should be well underlined as well. So here as I told you, this kind of thing I have done for you. Now we will look for the mechanism that what happens when we pass electric current, how this Al2O3 gets reduced. So what happens when we pass electric current? On passing electric current, obviously this Al2O3 will get dissociated to form their respective ions, right. As you know, the positively charged ion, where it moves, yes, you are right, it moves to the oppositely charged electrode. So obviously if it is a if the ion has a positive charge, it will move to the negative charge electrode, that is, it will move towards cathode, and this is going to move towards positively charged electrode, that is anode. Now on like moving to cathode and anode, they will be just performing their respective reactions. So just look at the board what kind of reactions they are going to perform. Again it is same, you know that at cathode reduction occur and at anode oxidation occur. So whenever you are doing electrolysis or you are doing electroplating or you are doing electrolytic reduction or you are doing electrolytic refining, whatever the process which involves the electrolysis, just keep in your mind that at cathode the reduction occur and at the anode the oxidation take place. So you need to remember that, because these reactions do not change, these basic reactions remains the same. So again at cathode what is going to happen? This is going to just accept its 3 electron back and forms the pure aluminium, right. So that means this electrode will be coated with the pure aluminium, right. And what is going to happen at anode? So which ion went to anode? Obviously it was O2 negative. 2 negative means it has already gained 2 electrons. So what it will do? It will just give those electrons back which it has already taken. So see, I am just writing minus 2 electron and it is forming O, right. As you know that O has a tendency to exist in nature in a diatomic form, that is O2, right. So that means this O atoms, 2 O atoms will be just combining mutually and forming a diatomic molecule, that is the O2. And moreover, you know that the electrodes are made up of graphite, which is again a form of carbon, and you are familiar with it that the carbon and the oxygen has a great tendency to combine along. So that means we will get to see that C plus O2 forms CO2 as well. So that means at anode we will get to see what kind of things we will get to see. We will get to see the O2 as well as the CO2, right. So why we did this process? You know that we did this process because we wanted that our metal should be separated from an oxygen. So this is how what we have done. Earlier it was Al2O3, now what we have got, cathode has a coating of aluminium, no oxygen, only aluminium. So that means the aluminium oxide is just reduced to an aluminium. This is what we wanted, that is why we performed this process, electrolytic reduction, right. So this is the whole process, like how you are going to do. Like as I took an example for aluminium, you can do it for any other case, but it is not always, keep in mind that we don't always add this cryolite or feldspar. Sometimes we need to add if we want to increase increase the melting point and we want to increase the degree of ionization, and sometimes we do not. If the electrolyte which we are using is already a good electrolyte, it dissociates completely, then there is no need to add something into it, right. So this is a process of electrolytic reduction, that is the process, third step of metallurgy, which deals with the conversion of metal oxide into a metal, and it is also a use of electrolysis.